On this video, I'm going to go through each one of the quiz questions, and it may not be your exact question because it pulled from a bank and there was about 8 to 10 questions of each type, but it should give you some insight into maybe what you had done wrong so you can figure that out, because these same sorts of questions might be asked on the test that's coming up soon. And also off to the side here, I've put where in class we had talked about it. So this question was like our Socrative, just so that you can see how important the Socratives are in our class discussions in our quiz and test banks that we pull. So this first question wants an equation of a tangent line, and when you hit on that phrase, equation of a tangent line, you should think, oh, okay, I just need a point and I need a slope. So you set about finding those two pieces of information. So my point is just my x value is this -5, and g of -5 gives me the y value. So my point is -5, -7, -5, -7. And then my slope is the derivative, because a derivative just means slope. And I see that my slope at -5 is 4. So my slope is going to be a 4. And now I go to point slope and write my equation. And here's my point slope version. So y minus my y equals my slope, and x minus my x. And on the actual quiz, you had to put this in slope-intercept form. So from there, I'm going to distribute the 4, gets me to here, and then subtract that 7 to bring it over. And then that would be the answer that I would input. The next question asks if a particular function is continuous, differentiable, both or neither at x equals 6. And again, you have a similar Socrative question that we had done in class. Let me go ahead and work out this quiz question. So to tell if a function is continuous, I need to go through that 3-part definition of continuity. Here's all the work to show a function's continuous. So my function is defined at x equals 6 and its value is 3. I do my left and my right hand limits to get 3, and that proves that the limit does exist and its value is 3. And then the last part is just stating that my limit value equals my function value, therefore f is continuous at x equals 6. And if I bypass this continuity part, then I need to check if the function's differentiable, and my first step is to find f prime. And I need to make sure that my slope coming from the left side of 6, because that's what f prime is, it's just a slope, is equal to my slope or my f prime coming from the right side of 6. So what I see is my slope coming from the left side is a 6 and from the right side is a 3. The mismatch in slopes means that this is going to join at a corner point. Therefore, this graph is not differentiable at x equals 6. And that reason is because my left and my right hand limits of that derivative are different. So because it was multiple choice, you could have done a lot of this informally, but here it is all laid out for you. On this question, I'm trying to find places where my function is continuous but not differentiable. So I would be looking for things like corner points, cusps, and vertical tangents. And as I trace along this graph, I see a corner point right here at x equals -6. So that is a value that my function's continuous but not differentiable, -6. And as I continue on, it looks like I hit a vertical tangent right here at -2. So I'm going to add -2 to my list. And at 1, I have a discontinuity. So it's a point of not being differentiable, but it's not continuous either. So I don't include that because I want continuous but not differentiable. And as I continue on, my last point is here at x equals 5. Some of the questions were worded slightly differently, and they might have said, give me all the points where f is not differentiable. And I didn't include this continuous portion. So you would just include 1 into your list. Our next question is going to ask us for the third derivative. That's what this notation means. In class, we had done a Socrative that outlaid that notation and also did an example with the second derivative. In doing this, if you were doing this on paper, and I know the way that we were doing it and you were just typing in your answers, it made it more difficult. But if you were doing it on paper, you would want to be very specific on how you got to that third derivative by laying out your first derivative, your second derivative, and then finally how you got to that third derivative. So my first derivative, I'm just going to power rule exactly what I see. So my first derivative is just a power rule, bring down the power and subtract 1 from the power. So I'm sitting here with my first derivative, and the second derivative means now just do another derivative on that answer, and it's just more power rule. And that gets me to 100x cubed, bring down the power, subtract 1 from the power, and here is my second derivative. And one more derivative to get to the third derivative. And I get my final answer is this 300x squared plus 24x. This question actually went very well on the quiz for most of you. If you missed it, it was probably just like a silly mistake, just forgetting to write a power or something minor. There were several questions where you had to do an error analysis, and they were all a little bit different, so I just pulled one of them. This one is asking you to write the equation of a normal line, and you had to analyze the student's work and find a mistake. And you really need to know what that word normal meant. And back in 2.3, we talked about a normal line, and all that means is perpendicular. So what I see in the student's work is they found this f prime of 7. That is the slope of the tangent line. But in order to write a normal line, I would have to do a perpendicular slope, which is the opposite reciprocal. So my correct slope in here should have been a negative 1 over 7. The next question asked you to find an approximation of f prime of 9 using the average rate of change. So here's a question from Socrative where we talked about what an average rate of change was, and that is just that formula f of b minus f of a over b minus a. And it is just your slope formula. So what we had to do on this one is, this is my x value of 9, so this is f prime of 9. So that is my x. And I had to find which interval that x would fall. So I look across my x row, and I find where the 9 would fit. And it fits right here in between the 8 and the 10. So that means I'm going to do my average rate of change on this portion of my table. So I find where that x value fits, and then I just do an average rate of change. My a and b are this 8 and 10. So that would leave me with f of 10 minus f of 8 over 10 minus 8. Some people left this as this form, but you have to, at a minimum, at least pull your numbers out of your table. So the next step is the minimum required work that you would have to show. So on a problem like this, it is a very popular kind of a problem. You would need to show me the numbers as they appear in the table. So I would need to see the 4, the 6, the 10, and the 8. So this actually would be an acceptable final answer. And some of you actually did that. You heard that message in class and you just gave that to me as an answer. Or you can go ahead and simplify it. And when I do the subtraction and divide it out, simplified, I get negative 1. So you can stop at the box, or you can just keep going with those calculations if you want to. Our next question deals with finding the coordinates of points where a graph has a horizontal tangent line. And over here we have our Socrative question that we talked about it in class. Doing it open-ended like you did on the quiz is a little bit different as far as your work requirements than what you have to show on this one, which was multiple choice, but I will talk about that as I go through this problem. So first, a horizontal tangent line. So that means the slope has to equal 0, because if you have a horizontal line going like this, it's going to have a slope of 0. And whenever you see this word slope, your mind should think that is just the derivative. So I need to take the derivative of my function using a power rule and set that equation equal to 0. And so I'm solving this equation here. So be careful you don't plug 0 in. I'm not trying to find the slope at 0. I want to know where the slope of the tangent line is 0. So now I'm left with this equation to solve, and I have a quadratic as shown by that power of 2. So I'm going to factor first. So I factor out my common factor of x, and then I set each factor equal to 0. So this is going to give me an x value of 0. And setting this one equal to 0 gives me a second value of x equals 2/3. Now, the way that this is worded, it says find the coordinates of the points. So what that wants is the x and the y coordinate. So really what should have been done is we should have found the y-coordinate that goes with each one of these x's by plugging them back into our f of x equation. So to find the y-coordinate for x equals 0, I would simply just find f of 0. So these were my coordinates, 0, 3, and 2/3, 85 27ths. So point-wise, doing this on an open-ended question, the necessary parts are for you to show the equation that you used to support your answer. So the equation that I needed to see wasn't just f prime. So I needed to see the f prime right here. We needed that to be equal to 0. And really, you should have given the full coordinates because of how this question was worded. But if you just gave the correct x values, then you received full credit. However, we were looking for the derivative to be written. We were looking for equals 0 because that is the equation that you're solving to be written on that question as well. The next question had you do a derivative of a radical as well as just testing to see if you knew what to do when x is in the denominator. Those were covered on some Socrative questions over here, as well as a bunch of Delta math questions. And this question on the quiz actually went pretty well for most of you. So my first order of business is to do a rewrite. So I have to rewrite that radical as a rational exponent, and it's always going to go power over root. And then when I go to rewrite this x in the denominator, I need to use a negative exponent so that x to the 4th goes up and joins that 3. And then from here, I just do a power rule. So I'm going to take my 2/5, going to bring it down in front of the x. And then I subtract 1 from 2/5. So just imagine yourself subtracting 5 over 5 to get that common denominator. And my new exponent is going to be a negative 3 over 5. The derivative of this 2, of any constant, is just going to be 0, so it's not going to show up in my derivative. And then on my power rule, I'm going to bring down my negative 4 exponent, multiply times the negative 3, and then subtract 1 from it. And our directions indicated that we wanted no negative exponents, so we had to take care of the negative exponents that are appearing. And all that's going to do is take that part and push it down to the denominator. And this equation shows that. So this negative 3/5 is going to go down and join that 5 where that negative goes positive. The x to the negative 5th goes below the 12. And again, that exponent goes from a negative to a positive. You could also rewrite that fractional exponent with a radical if you wanted to go back to that form. But we were happy if we just saw this answer was going to earn you full credit right here. On this question, I'm asked to find two variables, b and c, that make my function h differentiable at x equals 2, which is this point at which these two pieces of my function h are joining. Over here is the similar Socrative question that we had done. Over here we were finding values of a and b. And in order for this function to be differentiable, it first must be continuous. So this first part of what I'm going to do is based on continuity. And I can already see that my function h is defined at x equals 2 because this sign is underlined, meaning there's a part of this to follow for x equals 2. What I need to ensure is that step 2 of continuity, that value I'm approaching from the left and the y value I'm approaching from the right are equal to one another. And that gives me this equation here. So the limit as x approaches 2 from the left, that's this top piece. So I write it there. As I approach 2 from the right, following the bottom piece. And I need those two limits to equal one another. So now to evaluate these limits, I'm just going to do direct substitution. So my x is approaching 2. So each of these x's, I'm going to substitute in a 2. And evaluating the limits gives me this. And then I just pulled all these numbers together to call that a 4. And this is 2b plus c. And now I'm kind of stuck because I have two variables and only one equation, so I need to generate a second equation. So far all I've done so far is I've addressed the continuity that I need to happen, but now I'm going to address the differentiability. So over here I have found my derivative function, and I need the limit as x approaches 2 from the left to equal the limit as x approaches 2 from the right. So what I'm doing over here is I'm ensuring that the two pieces meet what I'm doing over here is I'm ensuring that they meet in a smooth manner so that those slopes just blend into each other so I don't create a corner point. And again, I'm going to evaluate these limits just by using direct substitution. So that 2 will get substituted in for those x's. And solving for b gives me a value of -8. And then to find the value of c, I come back over here to where I stopped. And now that I know that b is -8, I can replace the b right here with my -8 and solve for c. And that gives me a c value of 20. Our last question is the capacity in which you need to know that formal definition. Because we have the power rule, it makes no sense to go through all the algebra involved with this limit definition if we could just use the power rule. And we'll be learning a lot of other tips and tricks for finding derivatives that will make this not necessary. But you will get questions similar to what I have here. So the trick to this is realizing that this is the formal definition, and you can just see its relation to that formula. So what I have sitting in the front part here, this is all f of x plus h, and then my minus sign here is my subtraction. And then this, my f of x, is all of this. And notice what this limit definition is designed to do is to find the derivative, to find f prime of the f of x that's sitting right here. And you can see that in this definition. So my f of x is sitting right here, and this whole limit is designed to find its derivative. So if I can look here and I can spot my f of x is this function right here, I can just find its derivative another way, namely the power rule. And so if I were to go through and expand all of these binomials and distribute and simplify and then evaluate that limit, where I would end up is that 27x to the 8th minus 7x to the 6th minus 15x squared. So this is my answer here. So we hope going over this video helps you to see the mistakes you might have made on the quiz, and we hope that you learn from it. So if you see these questions again on the test, you will do better. The quiz in and of itself doesn't have a big impact on your grade. The purpose of it is just to reveal any deficits that you might have so that we can fix them before the test. If you have any other questions on this, please feel free to come see me or Mr. Patterson or Miss Underwood, and we will certainly help you out.